Hey everyone, welcome to this explainer. I am super excited about today's topic because we're looking at, honestly, one of the biggest, most exciting leaps in modern tech. We're going to explore how artificial intelligence is evolving from, just talking to us to actually going out into the digital world and getting stuff done. We're talking about a massive shift from conversation to actual execution, and trust me, it's a fascinating journey.
Okay, let's dive into this. Think about standard language models for a second. They're kind of trapped in a closed loop, right? They rely entirely on their parametric memory, basically just what they memorized during their training. So when you hit them with a complex, real-world question, they often just guess, and that guessing leads straight to those infamous hallucinations we've all seen. But what if they didn't have to guess? What if they could actually take action to figure it out?
Historically, these models relied purely on that memorized data to form their answers. It's like taking a test without being allowed to look at a textbook. But today, the absolute necessity is using external tools. By giving these models the ability to actively use the internet, or calculators, or live databases, we are fundamentally moving away from that old habit of guessing and arriving at actual, verified, grounded truth. Section 1. Enter the ReAct paradigm. So, to make this huge jump from guessing to grounding, we needed a completely new approach, right? A way for the language model to break out of its shell. And that's where ReAct comes in. ReAct simply stands for Reason plus Act. It's this ultimate prompting paradigm that bridges the gap. It takes the natural language reasoning of a model, its ability to understand logic, and combines it with the power to actually take actions using external tools. We are literally talking about giving the AI the keys to run a web search, fire up a calculator, or even execute code. It's a real game changer. Now, what's really interesting about this slide is the formal definition we have here. Take a look at that last sentence. The model explicitly alternates between thinking about what it needs and acting to obtain it. It isn't just blindly searching the web, and it's not just sitting there passively thinking. It's this active, dynamic cycle where the reasoning informs the action, and then that action informs the very next stage of reasoning. It's like a constant back and forth. Now, once you give an AI this amazing ability to reason and act, well, you're no longer just dealing with a simple chatbot. You've completely upgraded the system. You've created what's known as an AI agent. And an AI agent is essentially a system where the language model can actually plan out steps and take actions within its environment to accomplish a specific, complex goal. Notice how our source defines this. An AI agent accomplishes its goals by calling tools in a loop. So you see, ReAct isn't just some clever prompt trick you use once in a while. It is the common reasoning pattern. It's literally the core DNA, the very engine that makes these powerful autonomous AI agents possible in the first place. Section 2. The three-step ReAct loop. So how does this core DNA actually work in real time to solve a problem? Well, it operates as a repeating mechanical three-step loop. Let's break it down. Step 1. Thought. The model reasons about what it needs to do next. Step 2. Action. The model uses a tool, like hitting a search engine to find missing data. Step 3. Observation. The model reads the result from that tool. Thought, action, observation. This cycle just repeats over and over until the task is totally complete and it spits out a final accurate answer. So the crucial point is captured perfectly in this quote from our source right here. By grounding each step in real tool results, rather than relying only on memorized training data, ReAct reduces hallucination. This grounding process is absolutely critical. It gives the AI access to current information, external databases, or even a company's private data. That's what makes the AI incredibly reliable instead of just making things up. Section 3. ReAct in action. Okay, let's slow down time a bit and look at what happens under the hood with a real example. Imagine asking an AI this. How many children do the members of a band have in total? To us, it's a simple logic puzzle. But for a standard AI, oh man, it causes an absolute meltdown. It would have to perfectly recall the band members and their kids entirely from memory and then do the math completely blind. That is just a huge recipe for hallucination. But let's see how the ReAct loop handles it. Let's trace the logic we see here. First up, we get a thought. First, I need the list of band members. Then comes the action. It actively runs a search for the band. Then, observation. 4 members found. But wait, it's not done. Next thought, now find each member's number of children. It then triggers an action to search for member number 1's kids and repeats this for every single member. It observes and collects each count. Then we get a final thought, sum the counts. And finally, it delivers the total. Do you see that? It broke the whole problem down, used external tools for the pieces it didn't know, and built the answer piece by piece. And this brilliantly illustrates why ReAct is such a massive game changer. It absolutely does not guess. It retrieves each individual fact. It verifies the information through external tools before moving on. Because it works this way, it is highly, highly reliable for complex, fact-dependent tasks. It completely replaces the anxiety of AI hallucinations with the rock-solid security of a verified, step-by-step audit trail.
Section 4. The AI Agent Ecosystem. Zooming out from just a single query, ReAct is actually the foundation for an entire ecosystem of related AI technologies. Seriously, when you hear all these new buzzwords in the AI space today, they almost all trace their lineage straight back to this fundamental ability to link thought with external action. Our source highlights 3 major terms that you absolutely need to know.
Let's run through these real quick. First, tool or function calling. This is simply a model's specific ability to invoke an external capability, like a search engine or a database API, right in the middle of its response. Second is RAG, or Retrieval Augmented Generation. This uses the exact same principle of grounding we just talked about, but it specifically focuses on supplying the model with retrieved documents, ensuring its answers are tied to real, verifiable sources. And finally, agent frameworks. These are the actual software platforms out there, like LangChain or LangGraph, that developers use to easily build these tool-using agents. And the coolest part? All of these rely on the core ReAct loop principles.
Which brings us to the ultimate takeaway from today's explainer. We've seen how ReAct allows an AI to search the web and, do some basic math. But I want you to leave with this final provocative thought. What happens when AI can reason and act across any software tool? Imagine an AI agent that can autonomously navigate your calendar, draft your emails, pull data from your CRM, and execute entirely complex workflows all on its own, just by using that thought, action, observation loop. We are rapidly shifting from an era where AI merely talks to us to an era where AI actually works for us. And ReAct? It's the engine making the whole shebang happen. Thank you so much for joining me on this explainer. Keep learning, and I'll catch you next time.